Recording in progress.
The file can't be more than 30 MB. And so for the challenge itself, we have a sponsor track, the Woodwide AI sponsor track. We're going to judge on making meaningful use of all three APIs. So the goal is to build a workflow where you have a combination combination use of the different APIs to provide like a compound insight that a single model wouldn't give you. So you could cluster customers into segments, then predict churn risk, and then use anomalies to catch sudden behavior changes inside each segment or something like that. That's a lot different than just running individual analyses on like a data set. So that's what we're trying to show, and that's what we want to see you guys build. The winning submission also makes it really obvious who the user is and what decision they're making and why having those combined outputs is a lot more powerful in making that decision rather than just like summary statistics. So how to think about the APIs is really like high level. You can train your data set and then leverage inference calls as a way to create these interesting feedback loops across your data set. There's many ways to combine the primitives that we offer, and we're looking for creative use where it really solves a real world problem in a meaningful way. So you can pick any track to apply Woodwide AI APIs to, but also you can apply to our sponsor track as well. And the goal is to go beyond, simple summaries and historical data analysis to actually more proactive and predictive, actionable insights that your users can put into use in a real world setting. So we'll take a look at one sample use case of churn prediction. So here's like one way that you could use it, all three APIs. So you could do customer activity and payment history data and combine to look at clusters and identify behavioral segments. Then you could score each customer's churn probability and then layer in anomalies to flag those changes, like if there's a big drop in logins or that kind of thing. So then you can serve up like an actionable insight or a next step in your app, like a retention offer or something like that. So that's the kind of like compound insight that we are talking about. I'm going to hand it over now to Sailesh, who's going to do a live demo. And one of the kind of examples we're going to show you is this workflow of loading the data set, running anomalies, running predict, running cluster, and then combining those results. So I'll hand it over to you, Sailesh.
Yes, sounds good. Let me go ahead and share my screen here. Can everyone see my screen?
Yep.
Okay, cool. So I'm Sailesh, I'm engineer at Woodwide. I put together a little script here to walk us through the basic workflow of using the Woodwide API. So at each step in the script, so the script is going to be making various API calls to the API, and at each step, it'll print out exactly what code it's running, and it'll kind of explain what it's doing and how you can do it yourself. So let's go ahead and get started. I'll start running the script. So first, you have a data set. You're going to need to upload that data set. In this case, you want to upload like a training data set and a testing data set. For those not familiar, the idea is for your training data set, that's the data set that you're going to train your model on, right? You're going to teach your model about something. And then for the testing data set, the model's going to apply what it's learned from the training data set to unseen data. Right, so the testing data set is going to be the unseen data. The training data set is going to be the data that you teach the model with. So this here is the command that the script is about to run. This would also be how you interface with the API, right? So it's a simple REST API. We have different endpoints for doing different operations. So in this case, we would be making a post request to our API/datasets endpoint to upload a new data set. Because we want to upload our training data set. We're going to attach our CSV that we want to upload, right? That's our data set. It's going to have to be a CSV, okay? And this is how you attach it. You can give your data set a name, like in this case, I'm going to call it airline customers. This is going to be like a churn prediction kind of case, right, for airline customers. we can also, this flag is to determine whether you can, if you already have like a data set that's called airline customers, let's see, overwrite the same data set to something with already the same name. But that's the basic flow, right? You make a post request to API data sets, you give it the file that you want to upload, you give it like a name. Okay. And importantly, with every API call, you're going to have to include your API key in the authorization as an authorization bearer token. We'll give you your API keys later, but this is what's going to authorize you to use the API. None of your API calls will work unless you have your valid Woodwide API key. But yeah, and again, just one more thing. This URL is not the real URL. Later on, we'll show you what the real URL is, so you can go ahead and hit it. But this is the basic format. And so this is how you do it with curl. Like this is a shell script, so we're using curl. But of course, it's REST API. You can use any language you want. It's language agnostic. So here, for example, would be how you do it in JavaScript, right? Again, it's language agnostic. So you can do Python, Ruby, whatever you want to use. But this is how you do it in JavaScript. Again, the same idea. You make a post request to this. You give your API key. In the body, you have your file that you want to attach as your data sets and the arguments, right? Name and overwrite. Okay, so let's go ahead and upload this data set. Say yes. Okay, cool. So when you've uploaded data set, it'll give you a response saying that the data set has been uploaded, and it'll also give you the ID. The data set, so every artifact that you upload, whether it's data set or model or whatever, that will be assigned a unique ID that you can use to uniquely reference that ID. So this data set can be referenced with either this unique ID, if you're running a script or something, or you can reference it using this name, the data set name that you give. Yeah, so that's uploading a training data set. Now let's go ahead and talk about, okay, so first let's upload, now let's upload the test data set. Again, this is the same idea, but now we're uploading this different data set, this test data set, right? Let's go ahead and upload that. Give it a second. Okay, fantastic. So now again, so this new test data set has its unique ID and it has a unique name too. We give it a different name, airline customers test instead of just airline customers. Okay, so we've uploaded our training data set and our testing data set. Now we can go ahead and start training our model. So for example, suppose we want to do anomaly detection first. This is how you do it. So it's still a post request, but this time we're going to be doing it to API/model/anomaly/train. The idea, so the basic format is API models and then whatever the task type is. So we have anomaly, we have predict, we have cluster, we also have embedding. But yeah, put the task type here, and then you have the train for if you want to train something, or infer, which we'll see later on. But since we want to train a model, again, yeah, post to this URL, and we'll give it various parameters. So we'll give it the data set name will be airline customers. That's the data set that we actually want to train on, right? So train anomaly model on this data set, airline customers. This is referencing the training data set that we uploaded before. Again, we need our API key. Again, we can overwrite previous models with this. Oh, sorry. So we have a model name, this name that we now reference this model that we're about to train, this anomaly detection model that we're about to train. We can reference it via this unique name, airline model anomaly. That's the name we're going to give it. We're going to overwrite previous models with the same name. Okay, and then this is JavaScript equivalent. Again, same business, same format. This is just showing you that you can do any language that you want. Okay, so let's go ahead and start training our anomaly detection model. Okay, so now that it starts training, you can see that it's running now. Training is still going on. It's complete now, but I'll explain a little bit before we move on. Yes. So the idea is when you make this post request to train a model, you'll immediately get a response. And it'll give you the model ID, okay? The model ID of the thing you're training, model ID. And what you're going to have to do is you're going to have to poll via this get request to this URL API/model/ your model ID that you want to poll. This will tell you the status of that model, whether it's running or complete or whatever, right? So this will give you back a response that says training status, and it'll say either pending, running, or complete, right? So the idea is like you put this in some kind of loop, you keep checking it. Once the status is complete, you can then move on with the script. You now call inference with this model. Great, so that took a few seconds, now it's complete. So now let's run inference with this anomaly detection model. So now we're going to train our anomaly detection model. Now we actually want to see how it performs on new unseen data. So the way that's going to work is, yes, so API/model/anomaly/ the model ID that you want to run inference with. /infer, okay? And then you're going to specify the data set. You can either specify data set ID or data set name, but you specify the data set that you want to run inference on. This is not the same data set as the training data set. This is the testing data set, okay? So with this model identified with this unique ID, run inference on this data set, okay? So again, API key and all that still there. So let's go ahead and run inference on this new data. Okay, fantastic. So that was relatively quick. So now we have our anomaly results. So we've saved. So it gives us back a response. Let's go ahead and look at what the inference results look like. Go over here, anomaly results. Okay, so now you can see what the this is just pointing out. This is just a list of IDs that have been identified as unusual, right? So this is like, so if your data set looks like something like this, for example, this would, list out the IDs that were unusual, the customers in this data set. This is the customer data set. So the customers in this data set which were unusual for whatever reason. Okay, so that was running inference with anomaly detection. Let's go ahead and train a prediction model.
Thank you.
So
Thank you.
Training a prediction, sorry, someone saying something? Okay, training prediction model. So same thing here again, model / prediction this time, since you want, again, this is the task type, and then train, okay? We're training on the airline customers data set, the same data set that we uploaded before. We're going to call this and give this a new name, airline model prediction. And we're going to give it, we're going to specify for prediction, you're going to have to specify the label column, right? This is the thing that the prediction model needs to predict. In this case, we want to predict satisfaction, okay? Let's go ahead and train this prediction model. Okay, this will take a few seconds. Again, you have to go through this process of like polling this model to get its status, whether it's running or complete, pending, running, or complete. But it took a few seconds, but now it's complete. So we have our prediction model. Now, again, just like with an anomaly detection, we can run inference. So we specify the model ID, the prediction model ID that we just trained. Yep, same prediction model. We're going to specify the ID and then infer it on the same testing data set that we uploaded before. Let's go ahead and run inference. Okay, cool. So some spoilers there, but like, yeah, so we have a prediction inference. Let's go ahead and look at what it looks like. Yeah, so this tells us for every customer whether it's whether customer seems neutral or whether it seems dissatisfied or satisfied, basically. So these are the results of the prediction model. Okay, cool. So that was prediction. Now let's do something where we take the prediction results. So suppose we want to take the dissatisfied customers, and now we want to learn something more about them. Let's just look at the dissatisfied customers and try to understand, for example, what's driving dissatisfaction, right? So the way you do this is, scroll down a little bit. Yes. So given these prediction results, which tell us which customers are satisfied and dissatisfied, I have this little Python script that will filter out just its dissatisfied customers, right? It uses the prediction results response that we got and the data that we have and just selects exactly what customers were predicted to be dissatisfied by the Woodwide model. And it writes this to this dissatisfied.csv file. So now we want to cluster. We want to run clustering on this. We want to figure out the segments. We're going to figure the clusters in the dissatisfied customer data set, right, that we just created. So we've got to upload that data set so we can start to run clustering on it. Again, same stuff. I've already showed you how to upload a data set, same stuff, but different name, et cetera. Let's go ahead and upload that data set. Okay, that data set's uploaded. Now let's train a clustering model. Again, same format as before. This time you say clustering, okay, and we're training a model. We give the data set name. Again, this is the new data set name, right, that we just uploaded, just the dissatisfied customers, okay, API key and so on. Let's go ahead and run that. That will take a few seconds. Again, we have to go through this process of polling, checking the model status. This will take a few seconds. Okay, cool. Clustering model is trained. So now let's actually run inference, okay, on our test data set. Our dissatisfied customer data set. So again, so like post model slash task type, this time it's clustering, the model ID the trained model ID, right? Infer, and then dataset ID. This is the dataset ID of the dissatisfied customers that that were predicted, right? That we'd uploaded. Okay, so let's run inference. Okay, cool. That was pretty fast. Clustering results. So we've written the results back to this file. So let's go ahead and look at this file. Cool. So now this tells us the clusters that the customers fall into. So for each row, and again, notice this is how, let's actually check out our testing data set. Okay. Prediction. Yeah, there we go. Notice this is how the cluster labels are only for the dissatisfied customers, right? We've constructed the data set, so that's the case, right? You see 0, 1, 3, not 2. Okay, so for dissatisfied customers, how do we cluster them? Okay, so this now assigns for each customer a unique label from 0 to 7, so or probably from 1 to 7, so it's cluster them into 7 different groups. The response will also include AI generated but human readable descriptions of what these clusters mean. So each of these cluster labels is associated with a specific human readable description. So this, for example, has something to do with older female customers, right? So now you can understand what the kind of dissatisfied customers kind of cluster into. But that is the end-to-end workflow. So now hopefully you have some idea of how to interface with the one API. So I think we can take questions now.
Yeah, happy to take questions. I think there are a couple in the chat that we got. If you have any more, feel free to drop them in there. We'll also have links to, we'll drop in some links to docs as well as how you can sign up for the actual API keys. Give us a second. We'll share a quick overview on like what we'll be looking for from a actual judging criteria for the sponsor track. So we're going to be looking not only at use of a single API, but meaningful use of all 3 of them in a way that gives you compounded insights. We're also going to be looking at the actual problems that you're solving, the product thinking, and the technical execution. And in terms of resources and support, we'll have API docs for you guys. We'll have a quick start guide. We'll have some sample script to get you started, and you'll have access to the API keys on Saturday morning. So get yourself on the list, which we'll drop a link in the chat here so you can get signed up for that. And we'll have plenty of credits for you all. Everyone will have 200 credits, and you can use them as you see fit for your use cases between training and inference. So just so you know, each inference call is 1 credit and each training call is 4 credits. And then we'll also be available, Sailesh and I and the rest of our team will be on site, excited to meet you all to help with pretty much anything. So just holler. And the Woodwide AI Track Prize is going to be 1.5K with tech and swag as well. So we are super excited to see what you guys build. I think we have a couple minutes for questions, so happy to take whatever you got.
Yep, Eric, I think has a question.
Hi,
Hi, Eric.
thank you for the workshop. Quick question. So as early stage founders, can you walk us through your founder's journey? So how did you know your ideas were going to work? Like what challenges do you face and where do you seek mentorship and opportunities, etc.?
Oh, wow. That sounds like it could be a half-hour conversation. I'm going to suggest we take that one offline. But Eric, if you can find me, I'll be at the booth and we can definitely chat more. Feel free to reach out via LinkedIn too, and we can chat a lot more that way. We have 2 minutes, and someone's going to yell at me in a minute. So,
Oh, I did not notice. All right, thank you, thank you.
any other questions specific to the APIs that you saw today? All right. Well, otherwise, I will drop in. You guys can sign up for API key access on our website. Just click private beta access and you can put in your information. We'll get to everyone that way. You can also contact us through Slack and the next hack scheme.
Awesome. Cool.
Cool.
Very nice. All right, so I recorded this session. Let me just stop it now.